In this video, we're going to practice graphing the secant function. So I see that we have a regular secant function, except for there's a vertical shift of 3, which will affect the midline. Now, secant is the reciprocal of the cosine function. So that means your best bet is to basically graph the cosine function first, very lightly, and then we'll use that to determine what the secant function looks like. So let's see. First of all, the period of the secant function is the same as cosine. So the period will be 2 pi. Since there's no b value, or the b value is 1, so the period is going to stay 2 pi. Does everyone understand? This is not a phase shift. There's no parentheses. Okay, so this is not a phase shift of 3. This is a k value. This is up 3. All right, if this were in parentheses, then it would be a phase shift. Okay, so I'm going to go ahead and start drawing a cosine function then. So here I go. Well, it's going to be up 3, so let me leave myself space. So here's my x-axis for my cosine function, and here's a y-axis right here. It's going to be shifted up 3. So, and then the amplitude is 1, so I'm going to need to go as high as 4. So 1, 2, 3, 4. Okay. The midline is going to be at 3 now. Because it's up 3, the midline is going to be at 3. So you should have a dotted line up at 3 for the midline. I'm going to, on the x-axis, mark off 4 spaces. So 1, 2, 3, 4. So the period is 2 pi, so I'm going to just go ahead and put 2 pi over here. That means this is pi. That means this is pi over 2. That means this is 3 pi over 2. Time to sketch the graph of my cosine function. So looking at the midline, I know that the cosine function always starts off the a value above the midline. So since the a value is just 1, then I'm going to go 1 above the midline, and then the cosine function will fall back to the midline, and then it will be 1 below the midline, and then back to the midline again, and then it will end above the midline. So I am going to just draw the faintest, lightest possible version of cosine that I can. All right, because this is not the answer, but this is a guide that will show me where to put my secant function when I graph it. Okay? Now, because the secant function is 1 over the cosine, anywhere the cosine would have been 0, that's where the asymptotes happen. And before we shifted this midline was really the x-axis before. So picture this midline back when it was the x-axis, before the shift. So these 2 points here and here, I'm going to just make them a little darker. Those 2 points were the 0 points. So that's where the asymptotes are going to be. So there should be a vertical asymptote here and a vertical asymptote here. All right, it's where cosine was 0 before we shifted things around. Okay, so I know I'm going to have vertical asymptote in those 2 places. Okay, and now we've learned that the actual secant function will be the same as the cosine function at the highs and lows. So here, here, and here, these blue dots will be points on the actual secant function. And then now I'm just approaching the asymptotes. So I'm going to approach the asymptote, and here I'm going to approach the asymptote on the left and the right. And here I'm going to approach the asymptote like this. Okay, so that's what your graph should look like for this secant function. Any questions so far? There are actual people here, that's why I'm asking that. Yeah.
Like on the test or quiz, if we leave the cosine function there?
You can leave it just like I have it here. Just make sure you don't have it drawn in. Make sure it's like dotted and really light. But yeah, I expect you to leave it. I expect you to leave it. Okay, now answering the rest of these questions. Now right here where it says X-intercepts, there are X-intercepts. I can see like down here it is going to cross the X-axis, but finding the X-intercepts without a graphing calculator and when it's not hitting right at the lines is beyond the scope of this class. So let's just throw that question out. Skirt. And on a test or a quiz, I'll try to make sure that that doesn't even show up as one of the questions. But vertical asymptotes, we can talk about that. Vertical asymptotes are always going to be x equals something. Looking at the first positive vertical asymptote, I see pi over 2. So I'm going to say x equals pi over 2. All right, that's one vertical asymptote. And then if I go half of a period, I get to another vertical asymptote. Not a full period, half of a period. So I'm going to add half of a period. So the period was 2 pi. So half of a period is going to be pi. And then I'm going to put a variable on here as a multiplier. So I'll say pi n, or I could have said n pi. And so that's going to reflect if I added 1/2 of a period, or 2/2 of a period, or 3 pi, or 4 pi, or 5 pi. Every time I add n pi, I get a different vertical asymptote. You have to mention that n is an integer, meaning it could be positive numbers or negative numbers, getting you the asymptotes that go to the left. There was no phase shift, so I'll just put none. So let's do another secant function. This one has a phase shift to it. The period is still going to be 2 pi. Again, secant is 1 over the cosine. And cosine has a period of 2 pi, so does secant. There's no b value here, so the period's not going to change. We will do the x-intercepts and the vertical asymptotes at the end. The phase shift is right here. It's pi over 2. It's the opposite sign of what you have here in the equation. So it's positive pi over 2 to the right. Now, shout out to my boy Zach. All right, you ready? Special request. It's you and me on this one, buddy. Okay. Anytime there is a phase shift, I would recommend starting your graph with the phase shift. So that's what I'm going to do right now. Because this is 1 over cosine, what we do is we graph the cosine function first and then base the graph off of a sketch of the cosine function. So I'm going to graph the cosine function, but I'm going to make sure that I'm starting with the phase shift. So here's my x-axis. All right, it's shifting to the right a bit, so I am going to put it a little bit to the right instead of starting right at the beginning. So I'll put it right about, let's say, here. But I'm going to call it pi over 2 because of the phase shift. Now I'm just going to count over 4 spaces. So here I go. 1, 2, 3, 4. That should be where my period ends. Now I need to mark every one of these marks before I do anything else. So what I need to do when I have my phase shift, and I'm starting with that, I need to remember that every one of these marks is 1/4 of a period. So I need to figure out what is a quarter let me try that again. What is a quarter of a period so that I can add that repeatedly. So that's the question. What is a quarter period in this case? Well, the period is 2 pi. So a quarter period should be 2 pi divided by 4. And so that's going to simplify down to pi over 2. Well, that's going to make it really easy for this particular problem. Normally, I have to make sure that we have like denominators, but for this problem, they're already like denominators, so it's going to be a little extra easy. So starting with this pi over 2, I'm just going to begin adding pi over 2 over and over again. You know, I'm adding 1 pi over 2 each time. So this is pi over 2. So if I add pi over 2, I will have 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. All right? I'm just adding a quarter period. I'm adding 1 pi over 2 every time. Does that make sense so far? Yeah. Okay. I always put them down here below because usually at least one of them has to be reduced, and I like to leave space for that. So this one, for example, reduces down to just pi. Wait, I meant for that to be gray right now. This will reduce down to just pi. 3 pi over 2 doesn't reduce. 4 pi over 2 is 2 pi. 5 pi over 2 doesn't reduce. So these are the x values that everyone should be using right now. Now, I need to see where my y-axis is, though. I need to get the y-axis on here somewhere. So I am going to continue the pattern going to the left until I discover my y-axis. So I'm going to continue to the left. If I subtract pi over 2, well, I immediately run into 0. So there's my y-axis right there, just 1 over. All right, so fine. So I'm just going to put my y-axis, of course, will be right here at 0. So I'm done with this. Okay, so here's my y-axis at 0. All right, I needed my y-axis so that I can do my vertical shift and my amplitude stuff. So I'm going to go up 4. I'm going to go up to 5 to leave space for the a value of 1. So here I go. 1, 2, 3, 4, 5. Okay, so my midline is going to be at 4. So here's my midline. Now, I'm in the process of trying to draw the cosine function. So it would be helpful to see where my a values are going to go, my amplitude. So what I sometimes do is I put extra lines. I'm putting this in yellow. I know it's hard to see. That's because it's optional. But this yellow line is meant to reflect my amplitude, my a value. All right, my highs and lows. Okay, now I'm ready to sketch my cosine function. Starting at pi over 2, because that was my shift. So again, the cosine function starts off high, and then at the next position it's at the midline, and then we are low, below the midline, and then back to the midline, and then back at the maximum value again. So here's my cosine function. I'm just going to very lightly sketch it. All right, there's my cosine function. I've learned that there will be vertical asymptotes where the cosine hits the midline, because that's where cosine was 0 when we were dealing with the x-axis. And that's what creates asymptotes. All right? So there's going to be an asymptote here at pi, and there's going to be another one here at 2 pi. We have learned that the secant function will be the same as the cosine function at the highs and lows. So these 3 blue dots will be points on the secant function. So now I'm just going to approach the asymptotes. So I'm going to approach the asymptote over here. I'm going to approach the asymptote on the left and the right. And I'm going to approach the asymptote over here. Okay, and that's it for the graph. All right, does that make sense?
Yeah.
Okay. Again, for the X-intercepts, they exist, but finding them without a graphing calculator is beyond the scope of this class. So, skirt. Now, vertical asymptotes. We'll write that equation. Vertical asymptotes are always x equals something because it's a vertical line. The first positive vertical asymptote is here at pi, so I'm going to start with that. And then I see that if I go half of a period, I get to the next vertical asymptote. So I'm going to add half a period, and then I'll put in a variable for the multiples. So the period is 2 pi, so half of a period is pi. So I'm going to put pi n, or n pi, where n is an integer. All right, so this expression, as you change the n value, will reflect all of the vertical asymptotes going left and right to infinity. So that's it for problem number 30.